Hello everyone, I'm Alen Kahvedžić from Slovenia Post, and together with the researcher Miha Cimperman from Jozef Stefan Institute, we're going to talk about cognitive logistics for future cross-border exchange with the cognitive advisor tool. Together with 17 partners, we are developing a solution to solve the cross-border logistics. And in the following slides, we're going to present the solution that has been developed for right now. But in the next slide, we're going to show you a brief promo video of the project.
The world is evolving. Developing IoT and CPS technologies are already shaking up industries around the world, creating efficiency and improving services while lowering costs. The postal industry is no different. Social Internet of Things technologies create a paradigm whereby connected elements within a system or cognitive logistics objects communicate automatically within a cognitive logistics framework. This has the potential to benefit planning, route optimization, capacity sensing, and many more aspects of postal logistics. A CLO is always aware of its status, enabling smart reactions in responses to contextual changes. Optimal solutions are automatically presented to agents and communicated across devices. The COG-LO Project is developing a solution for the postal sector, which by taking a modular approach enables a more collaborative and cognitive utilization of postal infrastructure. COG-LO implements a fully decentralized network of postal resources, offering added security and greater potential for efficiency through AI. Actors cooperate in real time to optimize routes and deliver instructions to workers. State-of-the-art functionality delivered via COG-LO will take great strides towards the realization of Logistics 4.0 in the postal sector. Croatian Post and its partners are leading the charge worldwide in providing a modernized, efficient postal service for the future. So, what are the benefits at ground level? COG-LO will improve and expand same-day delivery, offer faster delivery overall, and reduce costs by working on principles of last-mile logistics. Behind the scenes, it's as simple as reacting to an event, checking available solutions, making the optimal decision, and implementing. For workers, this process will take place automatically, with the result delivered as a simple instruction via the connected smart device. COG-LO puts technology to work and passes the benefits to managers, employees, and ultimately the customers. An example to the world, a solution for all. Signed, sealed, delivered. COG-LO, making post smarter.
So the problem we are solving in our pilot of cross-border logistics is that we are currently having a very lengthy logistics chain with Croatia Post. If you look at the map that is on the slide, you can see that if you are sending a parcel from location A to location B, it has to go through a very, very lengthy process. That means from one logistics hub and the office of Exchange Ljubljana, and from Ljubljana to Zagreb, and from Zagreb to location B. So that means that we have a very, very rigid and predefined logistic route that is very unresponsive to any changes in the environment. So, for example, if we have a vehicle breakdown along the logistics chain, the system, we don't have any system in place that could respond to this deviation. And also, if there is any traffic interference, the driver has to communicate the change to the operations manager, and they have to readjust the whole logistics chain in their head and by hand. So there's also little to no interoperability between Croatia and Slovenia Post. We are just sharing shipment data between us just to ensure an easier logistics process between them. And also we have a lot of a big infrastructure network along the border, along with the pretty big delivery vehicle portfolio, which is not fully utilized right now. And for the end, we are currently not measuring the capacity of delivery of vehicles, so that means that we don't have information if vehicles are full or empty, so we don't know if we can dedicate parcels to them or not. The solution that our project is providing is that we want to install a cognitive logistics object. A cognitive logistic object can be anything in the logistics supply chain. So that means it can be a warehouse, it can be a delivery vehicle, it can be a post office, and it also can be a parking slot. And this cognitive logistics object has the ability to communicate with other CLOs and other actors along the supply chain, and with this communication and negotiation between them, they can deliver some optimal solution in the logistics chain. Everything is of course possible when we have the cognitive advisor, which suggests the most optimal solution when it comes to any deviation in the logistics supply chain. So when we apply the CLO and other technology in a logistics chain, we have the main objective that we would install a system or a mechanism that could respond to any changes in the environment. So this means that any ad hoc event such as traffic interference or border crossing closed or any other discrepancy can be resolved with this technology. So for, let's say that the shipment is accepted at the post office, it can be directly formatted into separate shipments and transported directly through the border to the other post office, that means from Croatia Post, and at that post the shipment, it can be processed and be headed to the last mile directly. This new system is of course possible because we have the necessary technology to do that. And also we can process, most importantly, we can process ad hoc events such as ad hoc demand for parcel delivery or any other event. So that means that the logistics supply chain is now responsive to any kind of change. So with this, we have shorter delivery routes and also lower cost for cross-border delivery. We can offer same-day delivery, and we can better the interoperability between postal operators. By this, we can optimize schedules, routes, and also we can offer more capacity in our delivery vehicles, and we can allocate shipments more efficiently. So if we go down to the operational specifics of the new scenario, as you can see on the picture, the whole point of installing the new technology and mechanisms is that we are bypassing the offices of exchange, which are main hubs for international shipment exchange. So that means that areas near the border have the ability to exchange shipments directly between them. With the newly installed system, we can utilize the infrastructure near the border and delivery vehicles more efficiently, and by that we will use the direct injection approach. That means that the shipments are physically transferred directly through the border, but the shipment data is transferred through the offices of exchange in Ljubljana and Zagreb respectively. At the end, we have to outline that every shipment transfer is compliant with international standards for shipments exchange. We know that we have to have all the papers along, and also we seal the vehicles, so to make this logistics chain as generic as possible.
Yes, so as Alen explained, we're trying to create a solution that is able to understand the logistics infrastructure as a digital object. So basically, before designing a solution, we defined a problem which can be extracted into three main events happening in the logistics infrastructure. And these are basically ad hoc requests, something that happens in time, new parcels coming into a certain point of logistics. Let's say like a post office. The second one was defined as a vehicle breakdown, so something that happens on logistics on distribution infrastructure. And the third part was any event related to logistics infrastructure, namely events such as border closed or roadblocks, which influences how the topology of distribution changes, and this is important because of the digitalization. So our approach was, as a scientific lead in the project, was to design the whole technological stack that can enable processing all the information in real time. So, so the basic components was social Internet of Things infrastructure combined with integration frameworks, and on top of that we built a cognitive advisor, which was an agent, able to process all the data of event in real time and create a corresponding response for optimization of actions. So going more into depth, we had on the one side SIoT infrastructure, which enabled us to get all the context surrounding the event. For example, when a vehicle breaks down, when there's a new ad hoc request, we're able to process the vehicles that are surrounded, which vehicles should be contacted, and what is the logistics infrastructure around the event. And of course, the integration infrastructure, which was able to route all the data, and beneath it was a distributed optimization infrastructure. So we were able to process optimization algorithms, how to do, let's say, optimization, optimal route planning based on the new events and so on. So just to explain briefly the main components, the SIoT was one of the core pillars of the project. The SIoT actually is able to somehow create context awareness. So basically, when there's an event happening, SIoT creates a social graph which shows us all the entities, all the vehicles, all the parcels, all the post offices that are in vicinity that needs to be included in new optimization plan creation, so forth. So and the second part was actually, so this was the SIoT, which was somehow, let's say, data infrastructure. The second data infrastructure where we get the data sources was post office IT system, so where we get like real-time data. And all this data gets processed by cognitive advisor tool at the end, which receives the data on event and creates digital representation of the whole infrastructure. Based on the digital representation in terms of a graph, which you see on the slide, that we're able to create the optimal response for the logistics based on the criteria that we have defined in the project as a key KPIs, key performance indicators, and create and call the optimization algorithms, which create new proposed plan for vehicles. So let's say so all the vehicles that were included in social graph gets new proposed plan, and this proposed plan gets sent back to SIoT, which creates we call it a negotiation. All the new plans needs to be confirmed by the end vehicles, either through mobile app or from onboard client. So basically the whole infrastructure state gets updated. At the end of the day, the cognitive logistic framework is able to build awareness of how logistics infrastructure is represented in real time. We call it a state, digital state. We built a representation. So just to give you some idea how the demo works, because at the end of the day, we put all the stack together. We used a regional representation of data. We used Google OpenStreetMaps data, and we used the simulator of traffic infrastructure to show how the real events are processed. And this will be shown in the next video. Okay, so this is the main use case, ad hoc order. So there will be a new parcel arriving at certain post office, namely this one, which will color the red, intraday. So we see a new vehicles arriving from depot, and then we will see a new event happening at certain location. And SIoT, you can see an SIoT graph on your left-hand side, and the event should happen about now. Okay, you see the SIoT received the data, and the data is being managed, and this is the response sent by the cognitive advisor for new vehicles and sent back to SIoT through mobile app, where it can be confirmed. The new proposed plan is confirmed via mobile app or onboard units or whatever the implementation end is, but mainly the vehicles get a notification that there has been an event, and certain vehicles need to respond. So we have a green colored vehicle who has responded to create a pickup, and he gets a new distribution plan, including the new parcels arriving. So in short, this is a presentation of how any event is being processed in cognitive logistics framework, also when vehicle breaks down and there's a border crossing closed, and so on. But the principle is the same, and the analytics behind it is presented in this main use case.
Thanks for listening. If you need any additional information about the project, you can go to our website, which is on the last slide. And if you need any other information, you can contact us directly through mail. Thank you.